let Cn into x minus a raised to n is a power series if for all x minus a modulus of x minus a less than r, this series if converges for all x minus a modulus less than r, this for this value this series converges, then that r is called as radius of convergence. If x minus a is less than r, modulus of x minus a is less than r, then if we remove this modulus means if minus 4 is there, minus 4 modulus means 4 modulus is 4. Similarly here x minus a modulus, if we remove modulus, then if x minus a modulus is less than r, then we can write it x minus a is greater than minus r and less than r, and x is greater than minus r plus a, and x is less than r plus a. So this is called as interval of convergence. Using this, how we can find out radius of convergence and interval of convergence of some problems. This is IIT mathematics exam problem. If minus 1 raised to n plus 1 into x minus 1 raised to n divided by n from n is equal to 1 to infinity, this is series, this is we can call as series. For example, what is series? For example, n is equal to 1 to infinity n. What this means? At n is equal to 1, this one is 1. At n is equal to 2, this is 2. At n is equal to 3, this is 3. At n is equal to 4, this is 4, up to infinity summation. So this is called as a series. We can directly say that this is a divergent series. Now here the same type, this is also one series. Now we have to find out the radius of convergence of this series and interval of convergence of this series. To find out radius of convergence of series, that means for which value x minus a less than r, this series converges. What is rules for convergence of series? We have some rules for convergence. If a series 1 divided by np converges if p is greater than 1 and diverges if p is less than or equal to 1, this is p series test, and this is ratio test. As n tends to infinity, an plus 1 divided by an is equal to p, then the series an diverges if modulus of p is greater than 1. The series an converges if p modulus of p is less than 1, and p is equal to 1 is inconclusive. And this is root test. If limit n tends to infinity, an raised to 1 by n is equal to p, then the series an converges for p is less than 1, and series an diverges for p is greater than 1. Now, and this is Leibniz test. For example, this is a alternative series. N is equal to 1 to infinity minus 1 raised to n is into un. How this is alternate? At n is equal to 1 minus 1 raised to 1, it is minus u1, and at n is equal to 2 minus 1 into minus 1 raised to 2 is plus 1. So it is plus u2 minus u3. This is called as alternatively minus and alternatively plus. So this is called as alternative series. For this series, converge this series, if n is limit n tends to infinity un, is equal to 0, then this series is convergent. So we have to know, to find out radius of convergence, these properties of convergence we have to know. Now here we can take, now consider an is equal to minus 1 raised to n plus 1 x minus 1 raised to n divided by n, and an plus 1 is equal to minus 1 raised to n plus 1 means n plus 2. Or we can remove this. Why? Because here minus 1 raised to 1 means minus 1, and minus 1 raised to 2 is plus 1, and minus 1 raised to 3 is minus 1. So this is alternatively, it give unit value. So we can take only this. An plus 1 is, we can take n plus 1 here, x minus 1 raised to n plus 1 divided by n plus 1. Now an plus 1 divided by an means we get this divided by this, x minus 1 raised to n plus 1 divided by n plus 1, this is an plus 1, divided by an, that is x minus 1 raised to n, here n. Now we get this and this cancels out, we get n divided by n plus 1, n divided by n plus 1, and x minus 1 raised to 1. Here this and this, dividing this and this, we get x minus 1. So we have ratio test, limit, as limit n tends to infinity, an plus 1 divided by an is equal to p. So if limit n tends to infinity, limit n tends to infinity, an plus 1 divided by an, this is modulus we have to take here, an plus 1 divided by an. So an plus 1 divided by an, if we take minus, we can take all, if we take minus 1 raised to n plus 1 here we get minus 1 raised to n plus 2, and on dividing we get here minus 1, but in modulus, on taking modulus, we get limit n tends to infinity, minus 1 become plus on taking this modulus, n divided by n plus 1 into x minus 1. So to become series convergent, we know that this is less than 1, that, or sorry, here this is p is less than 1, modulus of p is less than 1, that means this is less than 1 to become this series converge. To converge this series, this is less than 1. Then as limit n tends to infinity, what this become? As we know that limit n tends to infinity, we can write this as 1 divided by 1 plus 1 by n. If we divide numerator by 1, n, and denominator by n, we get 1 divided by 1 plus 1 by n into x minus 1 is less than or equal to 1. Now as limit n tends to infinity, this term becomes 0, and 1 plus 0 is 1, 1 divided by 1, we get x minus 1 is less than 1. less than 1. X minus 1 is less than 1. Modulus of x minus 1 is less than 1. For this, we know that what is we call radius of convergent. If this is a power series, then for all x minus a less than r, the series converges, then that r is called as radius of convergence. So here we can say that 1 is radius of convergence. Now, what is interval of convergence here? X minus, we can write x minus 1 is less than 1 and greater than minus 1. By taking this modulus, we can write minus 1 is less than x minus 1 and it is less than 1. So by this we can write, if we add minus 1 in all sides, we get add plus 1. If we add 1 for all side, 1 minus 1 is 0 is less than x minus 1 plus 1 is x. Adding all side, here also making plus 1, it becomes 0. X minus 1 plus 1 is x and 1 plus 1 is 2. So x lies between 0 to 2. This is interval of convergent, but we can here x is from 0 to 2. So this gives the interval x is from 0 to 2. Now we have to check what is at x is equal to 0 and what is at x is equal to 2. This interval shows the x belongs to 0 to 2, all real number from 0 to 2, but excluding 0 and 2. If x is equal to 2, what it becomes? If x is equal to 2, in this series if we put x is equal to 2, then what it becomes? N is equal to 1 to infinity. Take this series. If x is equal to 2, 2 minus 1 is 1. 1 raised to n is always 1. So we get, if x is equal to 2, then this series become minus 1 raised to n plus 1 divided by n. We get this series. Now we know that at n is equal to 1, this become 1 plus 1, that is plus 1. 1 divided by 1, so 1. At n is equal to 2, what it become? 2 plus 1 is 3. Minus 1 raised to 3 is minus 1. At n is equal to 2, it is minus 1 by 2. And at n is equal to 3, 3 plus 1 is 4. It is minus 1 raised to 4 means it is positive. So it become 1 by 3. So it is alternative series. So if we apply Leibniz theorem, Leibniz test, if we apply Leibniz test, then we get minus 1 raised to n here. So here minus 1 raised to n plus 1. What is in the place of un here? 1 by n is un here. We have to check what is limit n tends to infinity un. So here limit n tends to infinity n. What is limit n tends to infinity? 1 by n. We know that as n tends to infinity, this 1 by n becomes 0. So we can say that at x is equal to 2, this series convergent. So we can write interval of convergent includes 2. So we can say x belongs to 0 to 2. This is closed interval. This shows 2 is also includes. What if x is equal to 0? If we say x is equal to 0, what it becomes? If x is equal to 0 here, we get minus 1 raised to n. Here minus 1 raised to n plus 1. Then we get n is equal to 1 to infinity minus 1 raised to n plus 1 into minus 1 raised to n divided by n. Now what it becomes? Minus 1 raised to n into minus 1 raised to n plus 1. It becomes n is equal to 1 to infinity minus 1 divided by n. Now we know that this is not alternative series. Always it become at n is equal to 1 it is 1 minus 1, at n is equal to 2 it is minus 1 by 2, and so on. Now we have p series test. If n divided by 1 divided by n raised to p, it converges when p is greater than 1. It diverges when p is equal to 1 or less than 1. Here p is equal to 1. Here p is equal to 1. So this diverges. So here x is always, so this shows that x is not equal to 0 for convergence of this series. So we can say that interval of series is 0 to excluding 0, all real numbers from 0 to 2, excluding 0 and including 2. Here 2 we can include. If we include 2, we get convergent series. This is convergent series by Leibniz test. If we take x is equal to 0, then we get divergent series. So we can say interval of convergence is this one and radius of convergence is 1. Now second problem is two raised to 2n into x raised to n square. Now we know that limit n tends to infinity, an raised to 1 by n is equal to p. Then if p is less than 1, then this series converges. So if we take this root test, here we can apply root test here. So we have to get here limit n tends to infinity. We have to get answer for x. But if once we take root, then here n square. If we take x raised to n square 1 by n, then what it become? X raised to n. We have to know what is for x, we have to know. So put n square is equal to m. Then n is equal to root of m. So in the place of m, if we can put root of m, then this series become 2 raised to 2 root m into x raised to m. This series become this type. Now we know that as n tends to infinity, we can say n square is also tends to infinity. This is what implies as m is also tends to infinity. So we can apply root test to this. How? We can take am is equal to, here an is there, we can take am. What is am? 2 raised to 2 root m into x raised to m. Now what is am raised to 1 by m? Take 1 by m, then we get 2 raised to 2. If we divide root m by m, what is root m by m? It is equal to 1 by root m. So 2 divided by root m, here 2 into root m. When we apply this 1 by m, we get 2 divided by root m into x raised to m. Here m into 1 by m is 1. So we get x here. So what is limit m tends to infinity, am 1 by m. Limit m tends to infinity 2 raised to 2 into root m into x raised to 1. As m tends to infinity, this 2 divided by root m becomes 0. Limit m tends to infinity 2 divided by root m. is equal to 0. 2 raised to 0 means 1. So this is equal to x. So this is equal to x. We know that this converges when p is less than 1. So we can p is less than 1. That means here p means in the place of p here x. So when x is less than 1, this converges. So radius of convergence is, so radius of convergence is 1. For all x less than 1, this series converges. Now the next problem is, this is IIT Jam mathematics exam problem. We have to find out interval of convergence. We have to find out what is interval of convergence here. So now we can apply here ratio test. Now we can take an is equal to minus 3 n plus 2 n square plus 1 4x minus 12 raised to n, and an plus 1 is equal to 4x minus 12 n plus 1 divided by minus 3 n plus 1. Here n plus 2 is there. If we take n in the place of n plus 1, then n plus 1 plus 2, that is n plus 3. Here n square plus 1 in the place of n, here n plus 1 square plus 1. Now this is 4x minus 12 n plus 1 divided by minus 3 n plus 3 into, here n plus 1 whole square. What is expansion of this one? N square plus 2n plus 1. 1 plus 1. Now an plus 1 divided by an plus 1 divided by an. Now if we divide this one by this, what we get? An plus 1 divided by an, we get 4x minus 12. This divided by this, an plus 1 divided by an, we get 4x minus 12. What is this divided by this? Minus 3 raised to n plus 3 minus 3 raised to n plus 3 divided by minus 3 raised to n plus 2. We get minus 3 here. So here minus 3. What is this divided by this? N square plus 2n, here 1 plus 1 is 2, divided by n square plus 1. Now we can take modulus here. Limit n tends to infinity, an plus 1 divided by an is equal to limit n tends to infinity. Here n variable is this one and this is some other. We can take n variable in here. What is this become? N square plus 1. We can take here n square plus 1 divided by n square plus 2n plus 2. Now into 4x minus 12 divided by minus 3. Now we know that limit by ratio test, limit n tends to infinity an plus 1 divided by an modulus is less than 1 for convergence. So this is less than 1 for convergent. Now as we can write this limit n tends to infinity. If we divide this one by n square, we get 1 plus 1 by n square. If we divide this by n square, we get 1 plus 2 divided by n. N by n square is n plus 2 divided by n square. Into here minus 3 is here. If we take this from this modulus, 1 divided by minus 3. We can write 1 by minus 3 taking outside this modulus. So 1 by 3 we can take out this, and minus 4x minus 12 modulus is less than 1. Now as n tends to infinity, this one becomes 0, this is become 0, this is become 0. 1 divided by 1 is 1, and we can take this 3 to here. So 4x minus 12 modulus is less than 3. We can take this to here. Now here 4 is common here, so we can take 4 into x minus 3 is less than 3. Here if we take 4 from this, we can take 4 from this, so 4 3s are 12, so 4 into x minus 3, 4 into x is 4x, 4 into 3 is 12, so we can take outside 4. So what this is, modulus of x minus 3 is less than 3 divided by 4. So we can say 3 divided by 4 is radius of convergence of this series. Why? Because x minus a is less than some factor, then that series is convergent. For that we can say that this is radius of convergent. Now we have to find out interval of convergent. Interval of convergence. Now x minus 3, modulus of x minus 3 is less than 4 by 3, then x minus 3 is less than 3 by 4 is greater than minus 3 by 4. If we add all the part, if we add by 3, then we get plus 3. If we add 3 for each part, we get x minus 3 plus 3, it becomes 0. 3 divided by 4 plus 3. Now here 4, if 1 here 1 3 by 1, if we multiply by 4 here, here also we can multiply by 4. 3 into 4 is 12, minus 3 is less than x is less than 3 plus 12. Now 12 minus 3 is 9 by 4 is less than x is less than 15 by 4. Now this is one interval. Now here this and this excludes. This shows the interval x belongs to 9 by 4 from 4 to 15 by 4. Now we have to check what is at 9 by x is equal to 9 by 4, what it becomes. If x is equal to 9 by 4, then this series, if we apply in this series, we get 1 n is equal to 1 to infinity. If x is equal to 9 by 4, then 4 to 4, here 4 into, in the place of x, 9 by 4 minus 12 raised to n divided by minus 3 raised to n plus 2 n square plus 1. Now here 4 to 4 cancels out. Here 9 minus 12 is minus 3. Minus 3 raised to n divided by, we can write this as minus 3 raised to n into minus 3 raised to 2. We can split this as minus 3 raised to n into minus 3 raised to 2 into n square plus 1. Now this and this cancels out. Minus 3 raised to 2 is 9. So this series become n is equal to 1 to infinity. Here 9 into n square plus 1 here. Now we know that 1 divided by n square, from n is equal to 1 to infinity. By p series test, 1 divided by n is converges when p is greater than 1. Here 1 divided by n is converges. Why? Because here p is greater than 1. Here 1 divided by n square, from n is equal to 1 to infinity. So this is greater than this. Here n square is there. Here 9 into n square plus 1. So here n square plus 1. That means denominator is greater than this one. So since this is converges, we can say this is also converges. Why? Because, and we know that the series n is equal to 1 to infinity, 1 by n. This series also converges. Why? Because 1 divided by n raised to p. Here p is equal to 1. Then this also diverges. This is not converges. Since this is diverges. Now this is converges. So here 1 by n square, this series is converges. So this is some similar to this one. So we can say this is here, this series is converges. Here denominator is greater than this one. So this is less than this. This series is less than this series. So we can say that this is also converges. So at x is equal to 9 by 4, this series converges. Now at x is equal to 15 by 4, consider the same series. N is equal to 1 to infinity, minus 3 raised to n, we can write minus 3 raised to n plus 2s, minus 3 raised to n into minus 3 raised to 2 into n square plus 1. Here in the place of x, if we put 15 by 4 and 4 cancels out, 15 minus 12 raised to n. Now n is equal to 1 to infinity. 15 minus 12 is 3 raised to n, minus 3 raised to n. Here minus 3 raised to n here. Here minus 3 raised to n square is 9 into n square plus 1. Now 3 divided by minus 3 raised to n into 1 divided by 9 into n square plus 1. Here this and this cancels out. We get n is equal to 1 to infinity minus 1 raised to n into 1 divided by 9 into n square plus 1. We know that here 1 divided by n square from n is equal to 1 to infinity, this is converges by P series test. This series is convergent by P series test. Why? Because P is greater than 1. And here denominator is greater than this one. That means whole number is less than this one. Since this converges, this is also converges. By P series test, this is converges. And we can say that here by Leibniz test also, if minus 1 raised to n into un, then limit n tends to un is equal to 0, then this series converges. Here limit n tends to infinity un, that if that is equal to 0, then this series converges. Limit n tends to infinity 1 by 9 into n square plus 1 is equal to, as n tends to infinity, 1 by infinity is 0. So this is converges. So at x is equal to 15 by 4 also that converges. So we can say x belongs to 4 by 9 and 15 by 9 by 4 and 15 by 4. So x is lies in real number from 9 by 4 to 15 by 4. This also includes, or in other term we can write x is less than or equal to 15 by 4 and x is greater than or equal to 9 by 4. This is called as interval of convergence. In this interval, x is have these values, then this given series is converges. So this interval is called as interval of convergence of this given series.